I have a request to solve this problem 12, consider two vectors, and in the expert TA they want to know their magnitudes, and they give us they give us the vectors in this funny way here. The A vector is given like this, with an I hat, and a J hat, and these I hat and J hats are what they call unit vectors that point in one of the orthogonal component directions. So if we have an x and y axis, let's say, and here we're just going to consider 2D, just consider life in two dimensions. So here this is the y-axis and here is the x-axis. Then we could have vectors, and I would generally call them x hat and y hat, just because I like that notation. But there can be times when this other notation is good, and I'm about to tell you that these notations are equivalent. So a vector that points in the x direction, x hat, that has a magnitude equal to 1 and is dimensionless is what's called a unit vector. Here this is the x hat unit vector, so it's a vector of size 1. It points in the x direction. And similarly, I can construct such a vector that points in the y direction. We call that y hat. And the magnitude of y hat is also 1. Let's see. Look at the eraser here. Let me not worry about the magnitude just for a second. So x hat is a vector size 1 that points in the x direction. Y hat's a vector size 1 that points in the y direction. They're dimensionless unit vectors, and we can think of them as sticky tacks, if you like, that you tack onto a number that points that number or that magnitude in the direction that you want to go for it. And here, this is equivalent to I hat. And this one is equivalent to J hat. So they have these other names for them. I hat is equal to X hat, and J hat is equal to Y hat. And these are just a convention. So this could also be written as A1 X hat plus A2 Y hat. And this one could be written as B1 X hat plus B1 Y hat. And here and also I could write it in component form. This would be A1 comma A2. So this means that the vector has a component of A1 in the x direction and A2. This one is B1 B2. So this vector has an x component B1 and a y component B2, and similarly x component A1, y component A2. These all mean the same thing. That's also equivalent to this notation here. So there's all these notations that are equivalent. Let's just say, for example, I want to add these vectors, and I have, let's say, the vector A is equal to, say, 5 I hat plus 2 J hat. That would also be equivalent to 5x hat plus 2 y hat. Or that would be equivalent to 5 comma 2. And so what would that vector look like? It would look like going over 1, say 1, 2, 3, 4, 5 in the x direction, and then you have to go up 1, 2 in the y direction. So go up 1, 2 in the y direction, and then this would construct for you the vector A, assuming that was it. So it has 5 and 2. And maybe the units are meters, I don't know. Could be units, meters. And then let's say the vector B. And this would mean that, what would this mean? This would mean that this is A1. And this is A2. So here in this case, A1 would equal to 5, A2 would equal to 2. And now let's pick something else for B. Let's pick minus 3 x hat minus 4 y hat. for the b. And I could also write that as, and this I could write it as, here I'm mixing my notations. I guess when having so many, they could mix around. But at the end of the day, this would come out to -3 and -4. So if I look at this vector, what does that look like? It says to go, okay, go 1, 2, 3 in the negative x direction, and then go 1, 2, 3, 4, go down 4 in the y direction, and I maybe go a little further just because it doesn't seem like it's scaled right. So this would be the b vector. Now let's say I wanted to add a plus b. Okay, so what would I get if I did a plus b? And I still haven't answered the question. What would be the magnitude of the vector? Well, you can see the magnitude of any vector. So this is also equal to a1, and this one's equal to a2. So a1 and a2 form the hypotenuse of a right triangle. Oh, and I called this, I suddenly switched it. Oh yeah, they called it cap, and then the components so they're using caps for the vector, but lowercase for the component. So the magnitude of this vector would be a, that's just the size of the arrow. And what's the size of that arrow? That would just be equal to, from the Pythagorean theorem, a1 squared plus a2 squared, square root. And in this case, that would be the square root of 25, 5 squared plus 4, so would be the square root of 29. In this particular case, meters would be the units. Everything has units of meters if I pick that for the units of my vector. So that would be the magnitude of the vector. And the b one similarly. Here you can see this forms a hypotenuse of its own right triangle. It has sides. This has a side of b1, which is -3, a side b. So here it has a side b1. Here it has a side b2. The magnitude of the vector is b. So the magnitude of the vector would be similar like this. b1 squared plus b2 squared, all square root. Let's get back to just saying if I want to add them together here in this case, what would I get? All right, well, just doing the math here. So the sum of the components become the components of the sum. So what does that mean? So it means that I just add the x components to get the x component of the new vector. And so let's see, what's that? 5 minus 3 would be 2. And then 2 minus 4 will be -2. So this vector would be 2 in the x direction, -2 in the y direction. Let's see if we can try to just sketch this out for ourselves. So we could do our vector A. So our vector A, so let's go 1, 2, 3, 4, 5 in the x direction, and then up to 1, 2 in the y direction. So this is our vector A. And then to that we're going to add our vector B. So from here I'm just going to do tip to tail addition. So this one is going to go -3 in the x direction. 1, 2, 3, and then -4 in the y direction. 1, 2, 3, 4. So over from here, so I start to put the tail of this one at the tip of this one and go right down to there. So that's my b vector. So here's A and B. And you know, I've just kind of roughly scaled it. So here's A and here's B. Here I can see the sum vector starts from here and goes down to here. And let's see if it looks right. So it says to go 2 in the x direction and -2 in the y direction. So it's not quite square, so my scaling is a little off. But anyway, here's the sum. So it should be, the sides should both be the same. So I guess I scaled it a little wrong, but you know, you just get the rough picture of what the vector looks like. Anyway, you can see it has a positive x component goes in the positive x direction, and a negative y component goes down in the y direction. So that's how these vectors would add. And then the magnitudes, of course, is like I said. Okay, I hope that clears it up a little bit. So I'm just going to leave that right there. There's less than meets the eye with these vectors. Once you resolve them into the components, you can see the sum of the components become the components of the sum. That's just the way it goes with adding arrows. So work as many examples of that as you can, and then pretty soon this will just be second nature to you. And and sorry about this notation if it confuses you. There's really nothing special about it. It's just different ways to express the same thing. Oh, and last, I'll just say, okay, I was going to say the magnitude of these unit vectors are 1. Yeah, they all are size 1. So x hat and y hat equal 1, and j hat and k hat. These are equivalent. I hat is equal to x hat, j hat is equal to y hat. So they're just unit vectors that point in the component direction, and then you can think of them as sticky or arrow pointers that point your magnitude in the direction of interest, right? So this the I hat points the 5 in the x direction, so it says just to march 5 in the x direction. Similarly, the j hat tells the 2 to go that much in the y direction, go up 2 in the y direction. Or we could use x hat and y hat. It means the same thing. I generally stick with x hat and y hat unless it seems like there's a good reason to use I hat or j hat. Sometimes one notation could be preferable to another in different situations. But anyhow, just so now you've seen it, now you know. All right, go leave it there.